this today's LeetCode problem. This is student attendance record 2. It's a LeetCode hard one. So we will solve this. Let's see what the question is asking. Here we have given an attendance record for a student that can be represented as a string where each character signifies whether the student was absent, late or present on that day. The record only contains the following three characters: A for absent, L for late and P for present, right? So we have given this. So any student which is eligible for attendance reward if they meet both of the following criteria. The student was absent A for strictly fewer than 2 days total, okay, and the student was never late L for 3 or more consecutive days. Fine. So, and what we need to, so we have given an integer n, which is n is a number of days, I think. Yeah, n is a number of days here, and we need to return the number of possible attendance records of length n that make a student eligible for an attendance reward. The answer may be vary for that. Okay, so we need to find we need to find all possible attendance records of length n, right? Attendance records of length n, right? For making the student eligible for attendance reward, right? Students must be eligible for attendance reward, right? So student, when will a student eligible for attendance reward? When we follow these two constraints, like that the student should not be absent for strictly fewer than 2 days total. It means the student can absent less than two times, right? He can absent only two times, less than two times, right? Only one time, and he can never be late for three or more than consecutive times. What does it mean? It means he can late less than three times, right? So this two are the constraints here, basically, and we need to find by following these two constraints to find out how much find all the possible attendance records for length n. N is the days here, I think. Yeah, n is the days here. So if you see here, for n is equals to 2, this is the very short example. For n is equals to 2, how many possibilities, possible attendance records can be paired? So first thing is we can do present, right? The student is present at first day and the second day also. Second thing, he can be present at first day, next day absent. He can be present absent at first day, can be present, right? Now, what he can absent and absent also, because we are allowed. Sorry, we cannot do this. Why? Because he can absent only one times, right? Because here we have strictly fewer than 2 days total. It means this is not okay, right? This is not okay. This is not able. This is not a possible valid attendance record. So he can absent and late. This is valid. This is valid, right? He can late and absent. This is also valid. He can late consecutively because he can late less than three times, right? He can late and present. He can present and late, right? So if you see here, 3 and 3 6 plus 2 8, right? This is 8 combinations occurs. So that's why answer is here is 8, right? So this is how we will form the total number of combinations, right? So if you see what I need to what the constraints that we have given the constraints on A and L only, not on P, right? We have constraints only on A and L. And what are the constraints? That absent cannot be greater than equals to 2, and late cannot be greater than equals to 3, right? And if I see constraints here n is equals to 10 to the power 5, it means n is 10 to the power 5, 1e5. It means I can I cannot able to make uh, I cannot able to make possible. I need to anyhow I need to anyhow do this question in O of linear complexity, that is O of n, right? I cannot do this in O of n square of to the power n and all, right? So, but if you see here, I need to form all possibilities now. I need to form all possibilities. So how would I do that, right? So the first thing, if you see, the one thing is clear that I need to form. I need to see all possibilities. All possibilities. all possibilities, right? I need to form all possibilities. So for finding all possibilities, what we generally do, yes, we form a recursion. We form a recursion here, right? We will use recursion. So to analyze this, how we will use this recursion and how will I go move from this recursion to this 1e5, we will see the recursion tree by making it. So what are the constraints here? Let's see the constraint, right? Let's try to write constraints at one place, that L, and this should be a less than 2 and L this should be less than 3. That should be remembered here, right? And the days are and total days are n, right? So if you see, if I, so the one thing is clear, that I have two options. Either I can be late, either I have three options. Either I can be late, either I can be absent. If both of these are not, it means I am present, right? I have only three options. So if I start from absent and late both, so that will be 0 comma 0, right? So in this here, this is representing days, this is representing late, and this is representing absent, right? And if both of not is there, it means I'm present, right? Okay. Now one thing is clear here, that if I am present, okay, one thing I need to make you understand, that if I am present any day, if I am present any day, it means, it means I'm not consecutive late. The first thing is, here we have seen that we cannot be late consecutively 3 or more than 3 days. So if I'm not, if I'm present at any day, it means after that the consecutive days should be 0, started from 0, right? This is 0 days, 0 late, 0 late, consecutive days. Understood? Consecutive days, right? Because consecutive means it should be sequence. But if I present in any day between, it means the consecutive day will start from 0 again. This is the first thing which you need to remember, right? Which we make a which we remember throughout this process, right? Okay, so we have three options here. Either I am present. So if I am present, it means I will not increment this late or absent. This days will increment to 1, and this will be left to nothing and left to same, right? Okay. And if, what if I am, what if I am at one index, and what if I am not present, I am late, so it will be 1 and it is same again. What if I am absent? So it 0, it is same, and this absent should increment 1. Now again for every case, again for every case, each of this every case, we have again three possibilities, right? We have again three possibilities for each and every case. Now for this, for this 100, I have again three possibilities. I have again three possibilities, that is this, this, sorry, this is this, and this is this, right? Now if you see here, this is at the at the first day, that was the 0th day, this is the first day. Now at the first day, I have again three options. Either I can be present. If I present, this should be similar, this is 0 comma 0. Now the second option, let's make it an other, right? Let's do it in separately, right? So this 100, right? So again I have three options, again I have three options here. Either I can be present, either I will be late or absent. So if I am late, so this will be 1 and this will be 0. If I am present, if I am absent, so this will be 0 and this will be 1, right? Again, so this is how we will just form the recursion tree. So I am just uh, going to that last value, where will I return to, where will I return something. So I'm just making that. You can make all the possibilities by your own, by on paper or by anything you want, right? So suppose I'm just at 201 and given n is equals to 3, right? So I am at second index, I am at second part. So this 200 will have again three options. Either it will be present, either it will be present, or it will be absent or late, or it will be late, right? So if it is a present, then leave it, nothing will do. But if but if but if but if he is late or absent, I have again two choices. I again have choices, right? This 30, this has should be have 30, and this should be here, right? So I again have three choices. Like, if I am absent, if I'm late, then this should increment to 1, this should be 0. And if I am late, it means this should be 3, 0 and 1, right? Now if you see here, we have gotten at last position. It means I have completed my all days. So I have got some possible answers. It means from here I will return 1, because I got some answer, and we want only the numbers. We don't want exact possible strings. We only want numbers, so I will return 1 from here, because we have got at last positions and number of days. Same for this, same for this. And if you see, we are under constraints, we are within limits, this absent and late also, right? This is 1 and 1, and which is under constraint, so we will simply return 1 here, right? So from here it give me answer as 3. So what we are doing, we are just submitting, get submit sum the all the possibilities at last position, and we are just adding and return it to parent element, right? So we have got the 3 as an answer to its parent element. Now this 2 has 3 as an answer from one of the siblings. Now we will check all these possibilities, right? So let's analyze this also, right? So this will again give me some answers. Let's suppose this will give me B, this give me C, right? So 3 plus B plus C will get generated to its parent, this 100 here. So this has three parts, 3 plus B plus C, right? Same will go to its parent elements. Now this for 110, let's analyze for this 110 at here first. So here we have again two options. What are the options? Either it can be present, absent or late, the same thing. So if it is present, it means it should be left untouched, the absent and the late elements. But if it is late, it should be incremented to 2, right? And if it is absent, it should be incremented to 1, right? So now if you see, we are still under limits. But after this let's suppose we are looking for this 220, this 220, right? Let's take as a 220. So here we got 220. Again three types combinations. Either it can be present, absent or late. So if it is present, we will left untouched to late and absent variables, so that will become again same 20, right? But if it is late, then it will become, it will becomes 3, and this will become 0. But if you see, we cannot be the late cannot be consecutive, late cannot be greater than equals to 3, so this is not a valid case. So it means after this we are not able to move further. This should return 0 from here, because this is not a valid possible combination, right? But if it is absent, so it will give 1 only, right? This is a valid. So if you see, we are also at last days, and uh, we are also at greater than this late consecutive days and absent days. So if the valid combinations is present, it means we are returning 1, otherwise we are returning 0, right? If the valid combinations are there, it will return 1, otherwise it will return 0, and this will also return 1, because this is under constraint. So this will give me 1 plus 0 plus 1, that is 2, and this will return to its parent. So same here for case 210 and 20, and then summation to this parent, then for this parents to this parents, and lastly we will get all the combinations according to this. right? So if you see what we are doing, ultimately we are making possibilities. We are making possibilities, possibilities with with the given constraints, with the given constraints, right? So it's just a simple recursive which will be memoized, which we will memoized after seeing its recursion problem, right? Because ultimately we need to memoize it further because n is very large here. So anyhow we need to make it under this time constraints, right? So let's see how we can simply write this recursion implementation, right? So the first thing is we have given int n. So the first thing is this a number of days, the second thing is late, and the third is absent, right? So for that I need to just pass it along that. I will take days, I will take late, and I will take absent, right? And what I need to do, if the first thing is it can be present, it can be absent, and it can be late. So that there are three combinations possible. The first thing is either I can be present. If I am present, there will be no changes in late and absent, so that will be same. Okay, the thing is which I have told you earlier, that if I am present, it means, if I am present it means this late consecutive days should be zero. So if I am present, this should be zero, this should be zero. Why? Because if I am present, the consecutive days would become zero, because it is not consecutive again, right? So if I'm present, this should be zero, right? That something I missed to tell here in the recursion tree. So if I am present at some day, it means the consecutive days should be zero, right? Simply I pass a zero. Otherwise, if I am late, if I am late, I should increase it count by l plus 1. I should increase in count by l plus 1, and a should be same. And if I am absent, so if I am absent, l should be same, and a would be count incremented by 1 and passed it, right? And what are the total number of possibilities? It will be answer plus 1, answer 2, and answer 3. That's the whole possibilities which we will get by submitting it all possibilities. So when we will return this, when will this recursion will end? What the base case? So the base case would be, if I is greater than equals to n, it means we have covered all the days, and I definitely got a possible combinations. It means I will would return 1. But this l and a should have a constant, so which we need to check before that. So if l is greater than 2, sorry 3, or a is greater than 2, it means l should not be greater than equals to 3 and a should not be greater than equals to 2. Then we will simply return 0 from here if it is greater than. Before this condition I need to check this whether it is a valid combinations or not, and then I will return 1 from here. So this is a recursion. So it have 2 to the power 3, because for each and every places I have, each days I have 3 options, so it is 2 to power 2 to the power n, so 3 to the power n, right? So uh, I need to memorize it further. So for memorization, what we do, we just simply define a dp. So what are the changes parameter here? This is I is changing, L is changing, A is changing. So I will take definitely all the whole things. So if you see here, we have more constraints like 1e5, right? So I can accommodate all the combinations here, 1e5 for this, or and the maximum I can go L is 3, which is, so I can give 3 and it is 2, and initialize it further. So either I can like write this, or you can define it as a vector, 3D vector here, like this. This all both is true, right? So either you can define like this, or you can simply write, pass it like this 3D vector. Both you can write. So instead of this, I'm just using this to simplify the implementation part. right? Because here 1e5 is given, so the 3D vector can accommodate in globally, right? So I just need to initialize it with -1 initially for seeing that purpose, and after that I need to store this memoization in my answer, so that will be a. And before checking, I will check that whether this ILA exists previously or not. If it is overlapping, so I have definitely some values in my DP, so that will give me some answers here. So I will just return it from here. That will be a and right. Okay, the one thing is here that the answer can be very large and I need to return int, so I need to divide it by modulus. So I will take a mod value 1e9 plus 7, and if you see here, we are adding this, so this ultimately can go to the extent of bound of this int variable. So I will make this as a long not int, so this should be defined to long, just change this to long to handle the out of bound conditions, and this should be take modulus. That's it. I think this should be correct. Let's try to run this. uh, okay, this should be written as like 100 325 325, right? Let's run this now. N is not defined. I have not passed n here. Let's pass it. So n should be here, and this should be n, and this is n again, and this is n again. Now let's run this. Hmm. Okay, again some compilation error. uh, okay, this should be left out. Anything else need to comment? No, now it should work fine, I think. Again something wrong. What is wrong? So if I'm present, this should be absent, and if I'm not present, this should be l plus 1, and this should be l plus 1 again. uh, if it is greater than 3, I should return 0, or a is greater than 2, I should return 0. So if I is greater than equals to n, this should be return 1. If it is equals to -1, so uh, 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 what should be it? It is ILA, and this is I0 L plus 1. If I'm present, consecutive days would be 0 definitely. If I'm not present, it should be either late. This is for late, this is for present, and this is for absent, right? But what if I'm not absent, this should be L. Okay, if I'm absent, it means the consecutive days late should also be 0, right? If I'm absent, this should also be 0, right? Let's run now, because consecutive days means this should, yeah, let's pass, let's submit it. Yeah, we have successfully passed the sample case at all the submission. So what the time and the space complexity? So the time complexity would be, because we have memoized it, so we have successfully go from O of 3 and 2, O of n into 3 into 2, that would be O of n into 2 into 3, that is equals to ultimately O of n, right? And the space complexity would be, we are using whole of 1e5, right? So instead of there, you can pass it the n which is given. So either you can write it like this, or so that would be ultimately of n. I have just write one, taken 1e5 for for further implementation, for simplifying implementation, but the space complexity would be O of n into 2 into 3 only, right? That will be again O of n, right? and also a recursion stack would be there, and that would be again taken as O of n, right? So ultimately this should be O of n. So this is how we will solve the question. Thank you so much. Bye bye.